Hello. I'm continuing on with the base for the lime hand shaper, and I've been having problems with the machining because of the design of the mill. The fact that there's just one bolt that goes right the way through the base to the front end there, and that's the only thing that stops this column from moving. Now, under normal circumstances, I'm sure it's probably okay, but because I'm exceeding the capacity of the milling machine, it's become a problem. I've had it several times where the cutter has jammed and the column has moved, and because there is no information about the torque or maximum torque on the center bolt here, which looks about 1/2 inch, 5/8, I'm not sure. It's hard to know exactly how much torque you need to put on the bolt itself, and at the very beginning I guess it just wasn't tight enough. I've now applied more pressure on the, where are we here, on the wrench, and I've tightened it up to what I consider is pretty tight. There has been some conversation in the past that the plate underneath, this plate here, is not really, it could be thicker. It's welded onto the channel and or the square tubing, and it's not very thick, and so there have been some people that have mentioned that they've tightened the bolt up so tight that it's actually concaved this plate. So I really don't think it's that necessary. The fact that I'm machining a 0.1 depth at the moment with a 3/8 end mill, roughing end mill, and it hasn't moved on me lately. The last time it moved on me, I found that the nut was almost welding itself to the screw, to the thread. So the last time that it happened to me, I slackened off the nut. I managed to get it off. I thought the whole thread was undoing from this end. It was so tight, but luckily the nut did come loose, and so what I did was I applied some Loctite anti-seize on the thread, so I shouldn't have too much if I have to ever undo it. I don't think I will. This is asking an awful lot to machine this kind of application on a little mill like this, so I can't really fault it in any excess, except that I just don't like the design of the column. I would much prefer that the column was bolted in at least 2 other places opposite one another, down on these bosses. If you can see there, I'll try and get that out the way. These 2 bosses, if they were bigger, then it would be possible for Taig to apply a nice large tapered dowel going right the way through from the factory, and that would help to stop this column from shifting under a heavy load. Obviously the size of the machine and the situation of the type of work that you're going to be doing on this machine, normally it really doesn't warrant it, but it would have been nice. I mean, surely if you can improve a machine before it leaves the factory, then that is an added a plus for the company, in my estimation. A tapered plug with an extractor thread on the end. You could set up your tram and then put in your tapered dowel, say, I don't know, 1/2 inch the small end. It just means making larger bosses on the two mating surfaces, and once you've trammed it in, you just put the taper pin in there and tap it in there gently. And then if you do ever have to move the column for some reason, then you just eject the taper pin. It's easy, it's simple. You've just got to look at machines like Sierra FC3 milling machines, that quality of machine, and they do that automatically on the head, on the vertical head on the FC3. You tram the thing in, and then there's a nice big tapered dowel that goes in the side, and you just gently tap it to lock it in there. You don't hammer it in, you just tap it in lightly, and that helps to stabilize the headstock from twisting around on its pivot. So in my estimation, Taig would be a selling advantage as far as I'm concerned. There's been mentioned many times that the column moves under smaller jobs than this, and you get people building up great big trestles, steel trestles and angles and what have you, to support this thing up the top here. Under normal conditions, a tapered dowel would be, I'm sure, would be sufficient. So one of the projects that I'm going to do is, I've got some tapered dowels, I've got some tapered reamers, and just small number 4, I think it is. It's like 0.2 at the small end and 250 at the larger end. And as soon as I get this block off and I can tram this table in again, I'm going to put 2 tapered dowels in this crease here, the join in between the 2 mating surfaces, and I'm going to put one in this side and one on the opposite side, and that should help quite a bit when you're working on stuff as big as this. I can't fault the Taig. It's a nice little machine. It's just not what's the word? It's just not oh boy, I got thought loss. It's just not capable of doing, or as capable, I should say, not capable, but it is capable, but you have to be careful. I have around this side as an indication to indicate whether the column is shifting this way. This is a dangerous way to do a slot, because if you go too deep and you feed too fast, then there is a possibility that this column is going to move over, and that means your cutter's going to dig into the side and maybe break. So a couple of tapered dowels in each side would certainly give me a little bit more enthusiasm to do jobs like this. So I think that's about as much talking I should do. This is a picture of the, or this is a video of the new pulley system that I've got on there. And once again, I have to make an apology to Shoreline for their little DC motor. It's really standing up well to this kind of work. It wasn't. The belt was slipping with the smaller belt and the smaller pulleys, and I thought it was the motor was underpowered, but I have to concede that it was nothing to do with the motor. And as far as I'm concerned, it's a beautiful little motor. It's the right size for this machine. In the whole design of the unit, it's not a great big motor sitting on top of a little milling machine. And this system here has definitely improved the cutting of this material. One of the things that was a problem for me was that this was, I guess it was flame cut, laser cut, I don't know. It was obviously cut out of a large block of steel on the table, and the edges are rough, and at the same time they're also toughened up by the flame or the heat. So there's a tough skin which is not doing my cutters much good. And one of the other things that I have to say is that I'll just move around here, and I bought some of these holders from A to Z, and they work very fine. But if you're using a half-inch cutter and you're hitting on one side, especially on the tough exterior, that the set screw works loose, and so that's something that you should take note of if you're using these kind of adapters. There's not much meat there for the thread, and so what I did was I put some 242 Loctite on there, and I think that's going to solve the problem. But that's something you should watch, is to make sure that these set screws don't come loose while you're machining. But other than that, they're pretty handy, and if you've got several of them, you can set them up on height, and that's an advantage as well. So I just thought I'd mention that. I'll put that back down over there, and now I think I'll put the camera onto the stand, and I'll do some cuts and let you see how it responds. I have to take it easy because all the time this dial indicator, the needle is moving, and it doesn't take much to move this column if you use too heavy a feed. So I'll just continue now. I'm coming to the end of it. I've got pretty bored with this damn thing, really. It's been on here for probably a couple of months now, between waiting for cutters and what have you, and being away for a week. So it's been a bit of a headache now. It's becoming a headache. So I'm getting towards the end. I got this one slot here to do, and I'm just finishing off this slot, and then I'll put the T-cutter on, the T-nut cutter on, and do that side. And then of course I have to take this off and move it around. and this weighs about 56 pound. So all in all, the little machine, the Taig milling machine, is handling it really quite well. So if that's any use to anybody in deciding whether they wish to buy one of these machines, then let's hope that that helps them make that decision. Okay, I'll put the camera on the tripod and I'll continue machining. Okay, let's see, hold it there. There we go, just there. I think that's good enough. So it looks like it's still running, the camera. Okay, now what I've got here is a drip feed. That's all I'm using, and just a bottle up the top there. In fact, maybe I think before I do anything else, I'll just take this down and put some of that liquid that I collected. Oh dear. That's good. Just an old cheap Chinese drip feed thing. Well, it was supposed to be used under pressure, but it takes too much pressure, and my tank doesn't last long. So my compressed air is running all the time, and just a bloody nuisance. So okay, I don't know what I've got it running at. Let's see. I'll see if I can tell you. Let's see, we're there. That's 2. Should be about 500, I guess. I'll check on here. Yeah, 500 RPM. So let's see what happens. Come on. So let's see how that goes. Okay. Right. So I'll put 100 on. 100 thou. Wait until I get into the cut before I can put a quite possible that this column is going to move. It's very, very hairy working like this, because you never know when the column's going to let go. Add some drip. It's straining, you can tell it's kind of not cutting, and then all of a sudden it cuts under the extreme pressure. So if this was a solid column, I wouldn't worry so much. I'd put a bigger feed on. But because this column could let go at any moment, and you know, that would be a disaster. But you got to make do with what you got, I guess. The water, so it stopped. As soon as the water starts dripping nicely, the cut eases off and it gets better. Come on. Probably something blocking in the tube. Come on. Guess I'm gonna have to blow through, I think. What am I gonna do? What am I gonna do? Yeah, I need the air hose. Open it up. See where that goes. Oh. That's plugged up now. God damn it. Son of a gun. Oh, I'm going to have to cut the video off. This bloody thing. That's better. doesn't taste very good. Maybe I can carry on. That's better. That's better. Let's try that. Trials and tribulations. I've got to go down to a depth of, I think it's 550. So this depth is 0.2, so I got at least another 3-4 passes. The dial indicator is pretty steady. So that's a good thing. So then when I get down to the depth, then I have to open up each side so that the gap is 440 or plus on that, plus 440. See, now it's hitting the hard stuff. This is where you have to be careful because it could grab the climb. It's a nasty job really, because it's asking too much of the machine. Okay, that's that. If I can go down this way, I can actually cut down into the hard material. That helps a bit.